Everyone, myself Divyans. Again, we are going to teach some CSIR net problem, which is held on 27 July 2024. There is a question number 6, which is a part B. Okay, so here is the question. The question written as: let S be a dense of R and F mapping R tends to R. A given function define G mapping S tends to R and GS equal to Fx. Which of the following statement is necessarily true? So here is a what? First, see that here S be a dense. Okay. So first the concept comes in our mind, which is our dense asking about the dense set. Okay, and again here app mapping R tends to R, it means ki mapping from R real number to real number. And again another mapping which is from dense set S uh, mapping on R and by Gx is equal to Fx. So which of the following statement is necessarily true? So here is the option. If f is continuous on the set S, then f is continuous on the set R upon S. Our second option is if G is continuous, then f is continuous on the set S. And our third option is if G is identically 0 and f is continuous on the set R upon S, then f is identically 0. Last one is if G is identically 0 and f is continuous on the set S, then f is identically 0. So here is the question, and now we are going to solve this problem. Okay. So first of all, here is the concept used about dense set, and it is uh, it is necessarily imply or not imply on a continuous on all of R, especially on R upon S. So let's show that the concept. Okay. So if a function if a function is continuous if a function is continuous on a dense set on a dense set R on a dense set R dense set which is S, sorry, dense set is S. Okay, so it does not necessarily imply it does not necessarily imply that the function is continuous on all of R, especially on R upon S. Okay, R upon S, the complement of S in R. So our concept say that if a function is continuous, okay, if a function is continuous on a dense set S, so it does not necessarily imply that the function is continuous on all of R, especially on R upon S, the complement of S in R. So our first option is says that if a function is continuous on the set S, then f is continuous on f is continuous on the set R upon S. Okay. So how to think about this problem? If we think about the continuity on a dense subset S, so it does not imply the continuity of the whole set R. A function can be continuous on a dense subset, but except discontinuity is on R upon S. Therefore, the option is our first is incorrect. Okay. So again, One by one, we see the explanation. So our second option is says that if G is continuous, then F is continuous on the set S. So if G is defined on only S, we think about when G is defined only S, okay? So even if G is continuous on S, okay? So it says nothing about F dash S continuity on the rest of R. So continuity of G does not guarantee that continuity of F everywhere, hence the option is incorrect. Now the tell about the option 3. If gx is equal to fx is equal to 0, so for all x belong to s and which is dense in R, okay, and f is continuous on R upon s. So by the density of s, f must be 0 everywhere on R, because a continuous function on a dense set, that is 0, must be 0 on the entire set. Therefore the option C is correct. But tell about the option 4. If G is begin and identically 0 on S and F begin continuous on S, but it does not imply F is identically 0 on R upon S, continuity on set S does not extend to the whole set without further condition. Therefore the option is incorrect. Now again we see the explanation one by one, okay? So we are talking about the all option behind this question, okay? So come to the option and tell about the related option. So concepts says that what the concept says that about concept says that, okay, if a function is continuous, what if function is what continuous on a dense set S, then it doesn't it doesn't necessarily it does not necessarily imply that the function is continuous on all of R. So it's especially about the R upon S and the complement of S in R. So talking about option number 1, okay. So when we talk about the continuity, here is the option. Option says that first one is if f is continuous on the set S, then f is continuous on the set R upon S. So if talk about the continuity, so continuity on a dense subset S, it does not imply the continuity of the whole set R. Okay. When we talk about the continuity, okay, continuity on a dense subset S, so it does not imply continuity on the whole set R. Okay. And when a function is continuous on a dense subset, then its exhibit discontinuities on R upon S. Therefore, when a function is what? Function is a continuous. When function is continuous on a dense set S, then its then dense subset S, but discontinued it on R upon S. So their option is here and correct option. Now talk about option number 2. Option 2, when the option 2 says that, here is the option. Option 2 tells about the if g is continuous, then function is continuous on the set S. Okay. Here is the option. Therefore, we talk about the option number 2. Okay. If what if g is mapping on what g is mapping on S tends to R. Okay. If g is defined on S. Okay. So if even if g is continuous, if g is continuous on S, so it says nothing about f. Okay, it says nothing about f and continuity on the rest of R. Nothing about f dash s, f and continuity on the rest of R. So continuity does not guarantee that continuity of f everywhere. Okay. So continuity does not grant it the continuity of everywhere. So continuity does not grant it, does not imply f continuous continuity everywhere. So again the option number 2 is incorrect. Now we're talking about option number 3. Okay. So we are talking about option number 3 and 4. So our option 3 says that option 3 is talking about the g is identically 0 and f is continuous on the set R upon S, then f is identically 0. Okay. So we are talking about the option number 3. So if gx which is equal to function fx, if gx is function fx which is equal to 0 for all x belong to S. Okay. So S which is dense, which is dense in R, which is dense in R. So and our f is continuous on R by S. So there is a clear visibility. Please tell me in my comment section. R upon S by the density of S. When f must be 0 on R. Why? Because a continuous function, because a continuous function on a dense set, that is 0 must be 0 on the entire set. Okay. Therefore the option 3 is our absolutely correct option. Now talking about the option number 4. Our option 4 says that if G is identically 0 and F is continuous on the set S, then F is identically 0. But what we get if G is identically 0, begin identically 0 on S and F being continuous on S, so it does not imply, okay, F is identically 0 because 0 on R upon S. So continuity on S does not extend to the whole set, okay, to the whole set without further condition. Therefore, the option 4 is incorrect. So our option number 3 is correct. Now come to the next question. Okay, thanks for watching my videos.